Hey guys! So in this video we're going to go through and look at two specific example problems of how to use Hess's law and the relationships that you learned in the last video. So remember, if you reverse the equation, reverse the delta H sign, and if you adjust the equation by adding a coefficient, adjust the delta H by multiplying by that same number. So let's just jump in. So our first example, we want to calculate the delta H of this reaction given the equations below. So essentially what we have to do in order to find this reaction is adjust these two reactions across the bottom using the rules for Hess's law. So if I reverse my reaction, I have to reverse my delta H. If I multiply my reaction by 2, I have to multiply my delta H by 2. So the first thing I have to do is compare my chemical formulas to that reaction that's my final goal. So if I look at that final goal, I have H2O and C before the arrow, and CO and H2 after the arrow. So looking here, I can see I have H2, but it's on the wrong side of the arrow. So I'm going to go ahead and I'm going to flip this. And I'm going to have 2 H2O, 2H2 plus O2. I just reversed that arrow direction in order to reverse the reaction. So my delta H is positive 242 kilojoules. Now I'm going to do the same thing. I'm going to look at the second equation and compare it to my final goal. So my final goal has H2O and C before the arrow, and CO and H2 after the arrow. Here, that's again reversed. I have CO, but it's before the arrow. So I'm going to go ahead and flip this second one. So I'm going to have 2C plus O2, 2CO. And since I flipped that, I now have to reverse the sign of my delta H value. So now I'm going to drop a line down because this whole point is to try to make this final product. And when I drop a line down, I'm going to draw a new arrow. I'm going to combine the stuff on the left and combine the stuff on the right. So I'm going to do this in a different color. I have 2 H2O plus 2C plus O2 on the left of my line. On the right of my line, I have 2H2 plus O2 plus 2CO. Okay, now I want to cancel out anything that's on both sides of the line. So I'm going to cancel this O2 and this O2 because they're on both sides, so they don't really matter. Now I'm going to rewrite this in my original color. 2H2O plus 2C, 2H2 plus 2CO. Okay, and this has a delta H value of 242 minus 221, which is 21 kilojoules. Now, looking at this example and comparing it to my final goal, you should notice everything is correct. They might be in a different order, but that's okay. But I have extra coefficients that I don't want for my final answer. So here, I'm actually going to divide by 2. So all of these 2's are going to go away and we're going to simplify it out. So I have H2O plus C, H2 plus CO. And this delta H I also have to divide by 2, which is 10.5 kilojoules. So I'm going to circle that whole thing. I was able to go through, rearrange these two chemical formulas, simplify or cancel out anything that's on both sides, and then multiply or divide to make my final goal match my new chemical formula. So I'm able to determine that the delta H for this given equation is positive 10.5 kilojoules. Okay? Kind of overwhelming, I know. We're going to do one more, And then when I see you in class tomorrow, we're going to go through and do a couple more examples with me in the front of the classroom, okay? So here's our second example. And again, notice I have all of the arrows lined up, so I'm going to keep all of the arrows lined up. Then I have to combine them, cross out anything that's on both sides, and finalize and make sure it matches. So the first thing I have to look at, NO2. Well, that's not in my final equation, so that's something that's going to end up getting canceled out. H2, that's in my final equation, but it's on the other side of the arrow. So this first example, I'm going to flip because I want the H2 on the other side. So I have 2 NH3 plus 4 H2O, arrow, 2 NO2 plus 7 H2. So my delta H now becomes negative 57. Now our second equation, compare it back to our original problem. We are trying to solve for this chemical formula. So N2 happens to be on the second side of the arrow. Here it's on the first. So I'm going to go ahead and flip this because I want N2 on the other side. So 2 NO2 N2 plus 2O2. Just reverse that equation. So my delta H is now positive 33 kilojoules. In this last chemical reaction, we have H2 on the right-hand side of the equation. That's where it is here. But our issue is we have to compare it to the other things, because right now, before my arrow, I have NH3, which is good, but I also have H2O right here. And H2O is nowhere to be found in this. So I actually want to make sure that this H2O is on the other side of the arrow so I can cancel them out. So here, I'm going to flip. And I'm flipping because of that H2O value. So I have 2H2 plus O2 and 2H2O. Now I'm going to look back at this H2O up top. Notice that that has a 4 in front of it. So I actually want to multiply this by 2 because I need 4 H2Os to cancel. So this becomes 4H2 plus 2O2 and 4 H2Os. Alright, so now I reversed and doubled. So this delta H becomes 70 because I doubled and positive because I reversed. Now I'm going to drop this line down, and I'm actually going to write this on this side because I'm going to run out of space. My left-hand stuff I'm going to do in green again. So I have 2 NH3 plus 4 H2O plus 2 NO2 plus 4 H2 plus 2 O2. So that's all the stuff on the left-hand side of my arrow. On my right-hand side of my arrow, I have 2 NO2 plus 7 H2 plus N2 plus 2 O2 plus 4 H2O. Okay, now anything that's on both sides I want to cancel. So we are going to cancel this 4H2O on both sides. Cancel this 2O2, it's on both sides. Cancel this 2NO2, it's on both sides. Now, NH3 is not on both sides, but look, I have 7 H2s on the right, and I have 4 H2s on the left. So we're actually going to find the difference. Since this one has more, this one goes away, and I'm left with 3 H2s on the right. Okay, so now I'm going to rewrite it up next to our equation. I have 2 NH3, and that's all that's left on the left, plus 3 H2s, plus 1 n2. So that matches everything that's left down here, matches this final goal equation. Might be in a different order, but it's still there. So that means I have to take these delta h's and combine them. So I have negative 57, positive 33, and positive 70. And when we put those together, we have a total delta H value of 46. So this equation has positive 46 kilojoules, which means that it is absorbing 46 kilojoules from its surroundings. So this is technically our final step. So are you overwhelmed yet? Because this is what we're going to spend the rest of this unit doing. I want you to have this down. I want you to be practiced. I want to make sure that you understand it and see where we're going. Okay, so again, ask questions. This is one of the hardest things we are doing, but it's just like a big puzzle. Can you match the sides of the equation? Can you match the coefficients out front? And can you simplify out and cancel out things that are on both sides? So Hess's law is going to be our best friend for the next while. So I'll see you in class so we can go through some questions. We can talk about issues or concerns that you have, and most importantly, we can work through example problems together. This is something that we are going to spend time doing as a class to make sure you get it. Okay? So I'll see you tomorrow so we can sit down and take a look at this and work through them together. See you then.